Hello everybody. So in this video, I'm going to go over the difference and significance of sigma and pi bonds in organic molecules. Once again, understanding bonding in organic chemistry is key to understand reactions and to really fully understand organic chemistry per se. Okay, so in another video, I was discussing about how organic molecules were forming covalent bonds, right? So organic molecules are the results of atoms bonding to each other through covalent bonds. And remember how we define covalent bonds and those bonds in which electrons are shared in between two atoms, okay? So in terms of bond polarity, and based on electronegativity, we could classify covalent bonds, as I already explained in that video, into polar and nonpolar covalent bonds. Remember, based on electronegativity, when two atoms are having very similar electronegativities, let's say values of difference in electronegativity below zero point 0.5, we classify those covalent bonds as nonpolar covalent bonds, meaning that the electrons in those covalent bonds are pretty much equally shared. When there is a quite significant difference in electronegativity, once again, in terms of bond polarity, we classify the bond as polar covalent. In that case, is when the electronegativity value is between 0.5 and 1.9. Okay, so once you have once again two atoms with a significant difference in electronegativity, you will have a polar covalent bond. The electrons will be closer toward the highest electronegative atom, and that will create a dipole in the molecule, as I just explained in the other video, which is on the channel. So we can also classify covalent bonds in terms of the orbitals participating in that covalent bonds, okay? And that classification is really important and useful. And if we consider that, we could classify covalent bonds as sigma and pi bonds, okay? So what's the definition of a sigma bond? Guys, sigma comes from cylindrically symmetrical, okay? So it's a bond that is cylindrically symmetrical around the axis of the bond. So we have a sigma bond whenever there is a direct overlapping of atomic or hybrid orbitals. So I'm going to write over here, direct overlapping of atomic or hybrid orbitals. If you don't know what a hybrid orbitals, what is a hybrid orbital right now, that's okay. But I'll show you that. You can see that in another video here. But important thing for now is that you must understand that in the sigma bond, the overlapping in between the two orbitals participating is direct, and therefore the electron density is across the axis of the bond in between the two atoms. Okay, that's a really important thing to keep in mind. So if the electron density is cylindrically symmetrical around the two nucleus or in between the two nucleus of the atoms participating in the bonding. That is the definition of a sigma bond, okay? So what is a pi bond? So a pi bond is completely different. In that case, we talk about the side-by-side overlapping of pure p orbitals, okay? So side-by-side overlapping of pure p orbitals, that's the definition of a pi bond. Guys, big difference in between these two. The number one significant difference is the type of bonding. Sigma direct is strong. The electrons are in between the two nuclei. Pi side-by-side overlapping. Second difference, in sigma bond, only atomic or hybrid orbitals are participating. So you have a large variety of orbitals that can lead to a sigma bond. In pi bonds is the side-by-side overlapping only of pure p orbitals. Only p orbitals, pure p orbitals can lead to pi bonds. Because of this, guys, it's very important. If you have several pi bonds in a molecule, angle between pi bonds is always 90 degrees, okay? Why is that? Because remember that the angle between p orbitals in atomic orbital is also 90 degrees, okay? That's important because that talks about geometry in molecules. So if we apply this now to organic molecules, let's say a molecule like the one I'm showing here. So if you see molecules in which all you have is single bonds, right? All single bonds. So that's going to be all sigma bonds. So think about it, guys. A sigma bond is strong. It's the direct overlapping of atomic or hybrid orbitals, right? So how many sigma bonds can you have between two atoms? If the electrons are going to be in between the two nuclei, you can physically have only one sigma bond. There is no more physical space to have more than one sigma bond, okay? So if you have an organic molecule, every atom having single bonds, just single bonds, all these single bonds will be sigma. So I'm going to set single bonds only, all now what happens if instead of having only single bonds, let's say in a molecule like this now, let's say we have now one double bond, okay? So if I do that, obviously I have to remove one hydrogen on each carbon to respect the octet rule. So in that case, so if you have a double bond in between two atoms, one of these bonds is going to be sigma, as we just discussed. And since there is only room for one double bond, for one sigma bond, I'm sorry, so one is sigma and the second bond must be pi. So when you have a double bond, because there is only room for one sigma bond, one bond will be sigma and one will be pi. Okay? And if you happen to have a case in which you get an organic molecule having a triple bond, okay? Or I can say, let's do the same example here. Let's say we draw now replace this by hydrogen, and we're gonna add two bonds here. Okay, so in a molecule like this carbon has four single bonds. All these four single bonds are what? All sigma. However, this carbon has a triple bond. This carbon has a triple bond. Three bonds. So if you have three bonds, a triple bond, once again, there is only room for one sigma bond, so the remaining two must be pi bonds. What is the angle between these two pi bonds? 90 degrees, okay? When you have a sigma bond only and one pi bond, the angle between the sigma bond and the pi bond is once again, you have the sigma bond above and below the plane of the molecule. We can talk about geometry later, but for now, I just want to show you how do you know the number of sigma and pi bonds and the nature of this bond. So as a summary of this, sigma bonds, direct overlapping of atomic or hybrid orbitals as shown here in the picture. Pi bonds, side by side overlapping of pure p orbitals, only p orbitals participating in pi bonds. If you have several pi bonds, the angle between them will be 90 degrees, okay? So atoms showing only single bonds, atoms showing only single bonds, all these single bonds always will be sigma, like this. If you have atoms showing double bonds, because you can only have one sigma bond, the second bond must be pi. And if you have atoms showing triple bond, three bonds in between them. Because only one of them can be sigma, the remaining two must be pi, and the angle between them must be 90 degrees. Okay? Hope this was helpful. Once again, if you have questions, post it on the channel. I'll be happy to answer that.